Ji, Bismillah ar-Rahman ar-Rahim. Let's start discussing chapter 12, which covers the basics of algorithm design and problem solving. And this is part of your paper 2. The topic in Unit 12 starts off by discussing the basic definition of what an algorithm is. The algorithm is a sequence of steps that can be carried out to perform a specific task. So basically, this is the outline of what the program is supposed to be. And when we write, we want to write a particular software to achieve a particular task. We start off by writing an algorithm. All algorithms come equipped with basic constructs, including the assignment, in which a value is given to an identifier. We'll be discussing these things, what an identifier is and what a value being assigned to an identifier looks like. All algorithms must follow a sequence because your computer is a sequential machine. It carries out one instruction after the next, so you have to make sure the sequence is in line with our goals. We may want to our algorithm to behave differently with different inputs. So we may want to include some aspect of selections, and we may decide some steps are executed under some conditions and some steps are not executed under other conditions, so on and so forth. We may want part of the program to be repeated, and that's why we will have to have repetitions. And moreover, your algorithm must include some way for taking input from the user and processing the inputs and then presenting the results to the user in the user understandable form. Representing algorithms can be done in structured English, pseudocode, and flowchart. When we're talking about structured English, it has very minimal details, but it gives you an overview of how the algorithm will progress, moreover the steps, if there is a loop, so on and so forth. There is no details such as identifiers and variable names are not mentioned in structured English. It just gives you overall. It's like you were planning on what the algorithm should do in an informal way using plain simple English. But if you stick to some syntax that is not bound to some programming language, then you're making what is known as a pseudocode. Now, working pseudocode gives the benefit that we can translate this pseudocode into a high-level programming language quite easily because it's following some sort of syntax. And then flowchart is representing the same algorithm using symbols. Now let's look at the different symbols of flowchart and what they mean. So this is assignment and sequence. How do we know this is assignment? Well, it's in structured English, where as you can see here, I'm simply writing that A is being assigned the value 34, set A to 34. And if I want to increment something by adding the value by 1, we can do increment B. So these are two lines that are written in structured English. As you can see here, no symbols used, plain, simple, everyday English. Same thing, same two steps are carried out in pseudocode. This is what is known as the assignment symbol. So what's happening here is that 34 is being assigned to the identifier A. Identifier is a variable, is the name of the variable that we choose. So we'll be discussing that in a bit. Okay, what's happening here is this is known as increment. Adding the value, adding 1 to the existing value of B and updating the value of B. So this is this exact same statement written in pseudocode. As you can see here, that I'm also applying sequence. How is that being applied? Well, obviously the first line written will be executed first. So you have to make sure that the instructions that you want to execute in a certain step have to be written in those exact same steps because the program will execute them in those exact same steps. Now, this is what it looks like in flowchart. This is known as a process box. Whenever we're doing an assignment like this one, we will use a process box. Now, inside the process box, we can choose to write the structured English version of the algorithm or the pseudocode. Preferably, you will be using the pseudocode version. It's because it's easier to convert from pseudocode to flowchart. So if you write this exact same line in this box here, that's fine. Same thing goes with here. Instead of writing increment B, we can choose this line over here. Now, these are two process box, and these arrows are used to show the flow of the overall algorithm. So as you can see here, I wrote this line first, then this. So as same thing is the same sequence is being applied over here. This line set A to 34 is executed first, then incrementing this. And we have ensured that by making sure that in the flow, in the flow chart, the first line is executed, and this is the first line to be executed, followed by this one. Then this is how selection is taking place in structured English. The condition is represented in simple plain English. If this condition is true, then I'll execute these set of lines. If not, then see these set of lines. The same version, by the way, this is we're discussing selection now. If this condition is true, then these set of lines will execute, else these set of lines will execute. The same problem is implemented in flowchart using what is known as a decision box. It looks like a diamond, and it is. So the condition that I'm trying to test is mentioned here along with a question mark. If this condition is true, then I will take the yes path. If it's not, I will take the no path. So whenever you're using decision box, you have to make sure that you have two paths leading out. So as we'll be looking into this in a bit, but you will have to mention two paths, two alternate paths. Even if there's no else statement, you will have to still take an exit path for the second part, the second, the second situation. If this flowchart is not true, where will my program go if this situation is not true? You'll have to mention that path specifically. Okay, moving on. This is what it looks like for repeat until. It's actually it's an example of a repetition. There are many types. There are three types of loops. We're looking into that in a bit. So basically, if this condition is true, then this loop will run as long as this condition is true. Same thing is applied here using this pseudocode. So I'm repeating all of these statements written here until this condition is met. The same algorithm represented in a flowchart looks something like this. Now, this loop symbol right here, this shows the start of the loop. In fact, this ellipse is mentioned often at the start and end of all flowcharts. So you make sure you mention this at the start, at the end, or at the end of a flowchart. This here is specifically showing the start of a loop. Now, you don't really have to mention this loop. If you could connect this line directly with a straight line coming from here, and that's fine. Mostly flowcharts are written this way. But if you write mention a loop, it just makes it easier to understand where the loop exists in the flowchart. So from the looks of it, we can see that this entire sequence, as you can see here, this part of my flowchart is being repeated for a certain number of times. And that you would have been able to figure that out even if this loop symbol was not here. So anyway, all of these statements written inside this process box are being repeated and until this condition is true. So if this condition has not been yet met, we'll come back up, run these lines again, then test it again. So this is the working of a post condition loop. What that is, we'll discuss that in a bit. So moving here, taking an input and an output, they both use the same symbols. This is known as the input output box. So if I want to take an input, I will simply write input A in structured English. However, I'm allowed to add some sort of prompts. Now this prompt is basically a message presented to the user. So basically you can say enter a number, enter your age, or whatever. So whatever you message you want to present to the user, you can write it inside these double quotes and that will become your prompt. So in this line, we can see that three things are taking place. First of all, this message is being printed, user is giving some input, and lastly, that input is being stored in this variable A. Now, as you notice that if I want to use the input, this parallelogram as an input box, I'll have to mention the input statement inside the input keyword inside the statement. And that's exactly what's happening here. So this is what this input keyword is distinguishing between this statement as an input and this statement as an output box. Similarly, if you want to take an output, that means present some results on the screen, we can use the same box, but this time we're using the output message here. As you can see here, the pseudocode message, the pseudocode version of output statement has the output keyword followed by the prompt and followed by B. Now what's happening here is that I'm presenting this prompt followed by B. Now this B, you notice that it doesn't have double brackets, double quotes here. This means that this is an identifier and it has some value in it. That value is to be presented along with the message. So for example, if B had 5 in it, our screen would show message 5. So that's what it means here. Okay, now, as you can see here, when we talk about variables, what a variable is essentially, as the name suggests, it's supposed to vary during the execution of the code. That's right, it will vary. It's not meant to be finalized, not meant to be permanent. But what variable really is a space allocated in my main memory to hold some data that is supposed to be used during the execution. When I'm using a variable, the size of the variable depends on the type of variable. We'll be looking at those types in a bit. And the name of the variable is identifier. How do we write an identifier? Just make sure that you don't mention any keywords. Identifier should start with a letter and with it, it can use numbers. It should be only one word. And most importantly, if you want to make two words, make sure that they're separated by either using camel notation, that means capitalizing each word, or using an underscore between the two words. Finally, it is a good practice to make sure the key identifiers that you choose are meaningful so that anyone going through the code will understand what each identifier is meant to do. Apart from that, there are different operations that you can carry out with variables. For example, one of them is assigning a value. In assigning a value, I'm giving this number one to guesses. Now, what's happening in this line is that this one value is being assigned, so you see assignment symbol, assigned to the identified guesses. From this point onwards, guesses will hold the value one. Okay, we can also do assignment in this way that I ask the user to give some input. In which case, let's just say the user give an input 5. That 5 will be assigned the value number, to the variable number. So after this line, the variable number will have 5 in it. The second possible operation that you can carry out with variables is updating a value. So updating means that there are some contents in this variable, and I'm changing them and saving them in the same variable. So the previous value will be lost. So let's just say guesses had 1 in it. As you can see here, it had 1 in it. I add 1 plus 1, making it 2, and assigning that 2 to the guesses. So thereby overwriting the previous value. So this is what updating of an existing value means. I may want to copy the contents of from one variable to another. This is what it looks like over here. The contents of sum will be sent to total. Now, copying means that if say for example sum had 10 in it, that 10 goes total as well, and the 10 still remains in sum as well. So it's basically copying the contents of sum to total. They're also keeping a copy of the same contents in itself as well. If I want to swap the contents of two variables, this comes in handy when we'll be discussing bubble sort. When I want to swap the contents of two variables, I will have to make use of a third variable, a temporary variable, very aptly called temp. What's going to happen is that I'm going to save the contents of A in temp, because as soon as I do an assignment, the contents of a variable are overwritten. At one particular time, you only have one value in a variable. So what I do here is that I save the contents of A in temp. I copy the contents of B to A, and then I copy the contents of temp to B. So what happened here is that contents of A are saved in the temporary variable. I assign the contents of B to A. Now the A's original contents are lost, and it has now the contents of B. And temp, which had the very contents of A, will now be coming to B. Thereby, the contents of A and B are exchanged. Okay, so in your exam, you will be at some point required to possibly interpret between pseudocode, structure charts, and flow charts. So it's a very simple example how did that look like. For example, I want to take input of miles and converting it to kilometers and given an output. So that's the problem I had. That problem described in structured English looks something like this. Input number of miles, calculate number of kilometers, and output calculate result as kilometers, like so. This is what is known as an identifier table. Identifier table is usually given along with the problem. It mentions, it's simply there to outline what identifiers are being used in this algorithm and what their purposes are, just to give the code reader a better idea of what the algorithm is supposed to be doing. Identifier table may have details, of course, like the identifier itself, an explanation of what the identifier is supposed to do. And if it's a variable, it also mentions the type of variable. We're looking at those in a bit. So the type of variable is also mentioned here. And if it's an array of whatever it is, and some additional information is also mentioned here. So this is a simple example of what an identifier table may look like. So it comes in very handy when you're trying to understand what the problem does. And it also gives you an idea of what variables to use when you're writing a particular algorithm. So this problem written in structured English looks like this in pseudocode. Now, since I'm not doing it repeatedly, I'm only taking one input and converting it to kilometers and presenting an output. So there's no need of repetition here. It's only happening once. As mentioned before, these are the start and stop symbols, start and end symbol. So this is my flow chart. This is how it begins. I'll take the inputs in by the user, and the user will input the number of miles. I presented this prompt, the user gave an input, and that input is saved in this identifier. After that, in this process box, I'll multiply those miles by 1.6 and assign them to this identified kilometers. And at this At the last step, I will simply output, followed by this prompt, the kilometers that we calculated at this step, and that's it. The same problem represented in the pseudocode looks like this. Input number of miles, you can see here, the exact same lines written inside here are mentioned here. So no need the symbols, the exact same pseudocode line is mentioned here. So, and then this line followed, it comes after taking an input, kilometers is assigned with miles into 1.61. And then after that, I'm simply presenting the result of kilometers followed by the prompt of kilometers. So exact same code, but without these symbols. This is another example here in which I'm taking, basically I'm converting this pseudocode into flowchart. Now, as you can see here, I am taking some declarations before. Now, one thing to note here is that you don't need to carry out declarations in flowchart. So the paper usually mentions this as well, but we don't write declarations in flowcharts. We can ignore that step, but they are important part of your pseudocode, and we will be mentioning those in the pseudocode. Anyway, so after the declarations, I'm taking an input of a variable search value. I'm assigning my false found flag with false. I'm assigning my index with 1. I have this condition. This is known as a complex condition. Complex condition means that I am basically, this whole condition is made of 2 sub conditions, and this whole condition will become true if these 2 sub conditions are true, because we have an AND operator in between. We're looking at complex conditions in a bit. Anyway, this is a while loop. While loop is known as a precondition loop. While loop means that if this condition is true, this loop will keep on going, and it will terminate as soon as this condition becomes false. So I test out this condition. If this condition is true, then I have this if state here. Now, if is also another condition. I will check this other condition. If this is true as well, I will do this, and then I will exit my if block. If this condition is true or not, I will have to do this increment. So as you can notice here, this line is outside the if block. So it doesn't mean, it means that it's being executed regardless of whether this condition is true or not. So it's not part of the if block. It has to be executed compulsory. It has to be executed. Anyway, so when I exit the loop, I check if the found flag is true and with another condition. And if it's true, I will output not found. And if it's not true, I will do nothing. Okay, so as you can see here, there's no else condition here. But as mentioned before, that even if you don't have an else condition in your if flag, you'll have to show an alternate path in your pseudo flowchart. Now let's see how that looks like. So as mentioned before, I've got my input search value here. I will take my, as you can see here, this input output box, input search value. I make 2 assignments. Found flag is assigned with false, index is assigned with 1. Okay, as you can see here, there have been 2 process blocks being used here for separate assignments. You don't have to do that. You can do these 2 assignments in the same process box. Just make sure that the sequence is maintained. So first this line followed by this line, and they can be mentioned in the same process box, no problem. Okay, as you remember, the first thing I do is I ask this question: is this condition true? Then that's exactly what we're doing here. I'm checking out this condition is true. If is index less than 101 and is found flag equal to false, if yes, then I enter the loop. When entering the loop, I ask another question: is class name index is equal to search value? If yes, then do this and do this. Output index and found flag is true. And if it's not true, if this condition is not true, then I will not take this path, I will take this path. So if I end up here through this path, or I end up here through this path, I will still increment index as promised. So I will have to increment, this has to happen. I'll increment index, index is equal to index plus 1. I could have written this line here, no problem at all. Index is equal to, index is assigned with index plus 1. That is fine. That could have been written here. I will increment index, check for the condition again. If it's still true, enter the loop, do all of this again, increment index again, come back up here. If this condition is now false, that means it's time to exit the loop. I will go here, and then outside the loop, as you can see here, when I come outside the loop, I ask a question. That's exactly what I'm doing. I'm asking a question. If this condition is true, then I will output not found and exit. If this condition is true, I will output not found and exit. If this condition is false, there's nothing to do here. There's no alternate path for a condition being true. Found if found flag is true, any this condition is false, that means there is no alternate path. There's no else statement. How do we show that in a flowchart? As you can notice here, that if this condition is true, I take this path. But if the else state occurs, since it's not mentioned here, I will simply draw an alternate path that does nothing and simply guides you to the end of the program. That's it. It does nothing. So this is how you show your flowchart. This is how you cause your flowchart to lead to the end of the pseudocode if there is no else statement. This is what it looks like. So just an example of what you are required to do with respect to your pseudocode versus flowchart conversion. You will be required to do this at some point. You may be required to convert your flowchart to pseudocode. You will be required to interpret a flowchart and try to recreate it into pseudocode version. So whatever it is, you should be able to translate between flowcharts and pseudocodes. Okay, this is just different examples of how your pseudocode and flowchart translate. As you can see here, this is a post condition loop. As this was a precondition loop, I'm testing the condition first before entering the loop. This is a post condition loop in which I'm testing the condition after, and anything that's happening inside the loop. And then you notice that even here, there's this sequence of coming back and starting all over again. This is how I know that this flowchart contains a loop. I come back up again and start all over again. This is how I know it is a flowchart. Same thing over here, that I am coming back to the top and starting all over again. This is how I know there's a loop here. The difference is that I'm testing a condition first here. Here I'm doing the loop. I'm executing the loop body and then condition testing the condition afterwards. So this is what a post condition loop means. So afterwards, I have a couple of conditions to test. If this is true, then do this. Else if this is true, then do this. If none of these true, then we have this default condition which has to be executed. So if I exit the loop, if this is true, then I will assign this d is equal to 0, and I will do it exiting. If this is true, if I'll do this, then I'll exit. If neither one is true, then I will simply assign d with 0.2 as mentioned here and come back over here. Okay, by the way, if else statements are all mutually exclusive, so that means if you have three conditions and one or two conditions and one default state, only one of the states will be executed. It could be the first condition, two condition, second condition, or the default condition. Only one condition will execute. And this is known as mutually exclusive. Only one, and in fact, one will have to execute. So this is mutually exclusive statement. So if because of this condition being true, I had to execute this line, I don't need to bother about testing anything else because mutually exclusive statements. I will simply execute this line and exit my if block all together. So if this is not true, I will check this true. This is being true. If this is true, I will execute this line and I don't need to be concerned about anything else. If neither one is true, then this has to be true and I will execute this. So this is how mutually exclusive statements work. When I exit the if block, the first thing I do is I will assign cost with this calculation, this arithmetic operation, and then simply print out your cost of tickets, so on and so forth. So as you can see here, this process box is representing this operation, and this output box is representing this operation, and this is where I end. Okay, if say for example, we are calling a subroutine. What a subroutine is, we'll be discussing that in a bit, but subroutine process box looks like this. So if it's a procedure or it's a function, whatever it is, it's supposed to be mentioned in this type of symbol. This is whatever it is, whenever it's a subroutine, it's mentioned in this kind of flowchart symbol. Other than that, they're all the same. This is for specifically the flowchart symbols. As you can see here also, flowchart symbol is different for different procedures. Okay, now let's look at what logic statements are. In fact, we'll be looking at these in a bit, but this is an example of logic statement, such a logic statement that possibly applies all of the different variations that you see. So basically, logic statement can be represented in two ways. We got case of otherwise end case, and we got a simple if then else statements. Let's look at the if then else statements here. in if then else statements, I test a condition, and if that condition is true, then I will execute its code. And if it's not condition, if that condition is not true, then I'll take some alternate path. Now, if then else statements have different variations. For example, I can have a simple condition like so. I can have a nested if condition like so. I can have complex conditions, and all they can be some default condition. Now let's see what's happening here. This particular problem takes an input from the user, and if the number is positive, it decides if it's greater than 10, lies between 5 and 10 inclusive, or is it less than 10. But the number has to be positive. So if the number is not positive, then I do not have to bother about testing these conditions. So this is an ideal situation where nested if conditions should be used. So if the number is positive, then I will check if the number is 10, greater than 10. If that happens, then I will output this and nothing else matters. Only this statement is done. If this condition is not true, it's not greater than 10, then I will check if this is true. By the way, this is my simple condition. These are both simple conditions, but this is actually an example of a nested if state. Why? I test this condition only if this condition is true. So this, as you can notice here, this I'm using indentation. Now, because of this indentation, these gaps, we can very easily identify that this whole if block is actually part of the, the body, the execution body, the statements of this if statement. So which means is that this if condition will only be tested if this condition is true. So this is what a nested if looks like. So if this is a nested if, and it's also a simple condition because there's only one state to test. This is a complex condition. As mentioned before, these two conditions have to be true for this entire condition to be true. And this is a default condition. There's a default state. There's no condition to be tested. It just simply executes this line. So if the number is greater than 0, only then I bother about whether it's greater than 10, between 5 or 10, or less than 5. So if either one of these states is true, I will execute one of these lines and exit the if block altogether. But if this is not true, then I will simply jump and skip all of these lines and print this on my way out of this if block. So this is how my nested if works. Coming on the second variation of our statements, this is known as the case of otherwise end case. Now, basically, case of otherwise end case statement looks something like this. That let's just say, for example, I want to take an input from the user, and if that input has one of these values, then I can simply execute these lines and be done with it. So I know it's a similar way of working. I mean, that's true actually. I can implement this exact same problem using if else statements as well. But at sometimes it's just easier to code when you're using case of. Python doesn't have case of, so you're gonna have to work with if else anyway. So, but this is just another way, different way of applying selection statements. So if I will choose this variable choice, and I will be elaborating I will be looking into the contents of choice. And if the contents of choice are 1, then I will do this. If they're 2, then I'll do this. If 3, I'll do this. And 4, I'll do this. Okay. If they're nothing, neither one of these things, then I will simply go to the default state, which is the otherwise state, and execute this. Now, one thing to note here is that when you're writing a case of statement, a decision, there's only one decision being made, as opposed to having multiple if statements here, multiple decisions taking place. In a case of, there's only one decision being taking place, and that decision is that whether the contents of choice are amongst these values or not. That's it. So if that decision leads to us having one of these values of this, then only then I'll progress forward and execute one of these lines. If the choice contents do not have any values from this, then I'll simply go to the otherwise step. So there's only one decision taking place. So that's why the flowchart of a case of statement looks different too. Let's look at that. As you can see here, I have a flowchart that's representing this case of selection statement. As you can see here, this part of the code, I'm performing a case of elaboration on player game grade. So if the contents of player game grade are B, C, or D, then I will choose one of these paths. But if they're not one of these, I will simply go to the what you call it, the otherwise or the otherwise state. Now, otherwise not mentioned here, but if it was, then we can have otherwise here before the end case. There's no default states are optional, by the way. You don't have to have them. So anyway, now check this out. I'm only going to perform one decision. Is player game grade from these three values or not? If it is, then I will be executing one of these lines. If it's not, then I won't be doing anything. And that's how it can be seen here in the flowchart. Only one decision is taking place. That M is does case player game grade have one of these values? If yes, then I will take this path. If no, then I will skip everything and simply come here to the line written after my case of statements. Now, if this statement is true, or if my statement is true, meaning that the contents of player game grade are B, C, or D, in that case, I will move here. If it's B, then I will execute this line, exit. If it's C, I will execute this line, exit. If it's D, I'll execute this line and then exit. So whatever it is, decision is only made once. Moving on to my repetitions, as you can see here, I may want to have some choices in my code. So for that, I have three options. I can use the counter control loop versus two conditional loops. Now this conditional loop requires my condition to be tested after. This will require my condition to be tested first. And this is my counter control loop to be used only when I know how many times the loop is supposed to run. So as you can see here, my loop here is running 9 times. What it's doing inside the loop is that simply comparing a number. If it's bigger than the biggest number, it replaces the biggest number, so on and so forth. But what's happening is that this loop is running 9 times. Now, important parts of my for loop structure. This between my for and end for lies my loop body. So anything written inside this part is to be repeated. So all of these lines is repeated, including this next statement. Basically, when one time the whole body is executed, my code will check if the counter, now basically counter is controlling how many times this loop is run. So basically my counter starting from 1 to 9 will cause this loop to run 9 times. So basically when I run this line once, my counter is tested. My counter is incremented because of this next line. This next increments my counter. So if I started off with counter 1, it hits next, now counter becomes 2, so on and so forth. So every time my counter is incremented, I go back up and test whether if I'm still under my range, that is 1 to 9. So if I'm still within that range, I will run it one more time. Another next, I'll check again. Another next, I'll check again. So when I reach 9, I'll run it last time. Now next will cause the counter to become 10. So 10, since it has exceeded the range, I will run this loop no more. So what it means is that even if the counter is used here and the number of iterations are controlled, they're predefined, even then my counter is tested after each iteration. So, and any statements that's written outside these for and end for statements occur only once. So this statement occurs before the loop starts and this statement occurs after the loop starts. Same thing goes over here, but the difference is that repeat until loop is not counter control. It's a different thing that I've implemented the exact same problem here using a repeat until loop. And of course, by default, repeat until or while loop don't have counter controlling mechanisms. They don't have the next. So we have to apply our own version of counter incrementation here by making counter is counter plus 1. So I will take an input biggest so far outside the loop, and after the loop, I will print the biggest so far. So as you can see here, these two lines are not part of the loop. So this is happening before the loop, this is happening after. Any line that is lying between the repeat and until constructs are being repeated. So this is post condition loop, which means that this will run at least once. It will have to run. The condition is tested after the whole body is executed, and this loop will keep on running until this condition is true. So if I run this loop and the condition has not been met, I'll go back and run it again. So I'll keep on running it until this condition is true. Repeat until loop is a good way to run a loop if my exiting the loop depends on my input. That means I will have to take one input at least, and that input will lie somewhere inside the loop. So if you're, for example, doing some sort of validation check, then you will have to do repeat until loop. Not have to, because Python doesn't do repeat until loop. Python doesn't have the repeat until loop option. But what it means is that you can do it as the same exact same problem you can be solving with while loop as well. Anyway, coming to while loop. Now, while loop is known as precondition. This is post condition. I'm testing the condition afterwards. This is precondition, where I'm testing the condition first. As you can see here, this condition is tested before the loop starts. Now, the thing about while loop is that it may not run at all. So it's starting to run for the first time, and condition is tested, and condition is already false. I will exit the loop. I won't run it at all. So while loop doesn't need to run if it doesn't if it doesn't need to run, it won't run. Repeat until loop will run at least once. So there's an added benefit with while loop, because it's possible that it won't need to run, it won't run. So that's the benefit of a while loop. It requires lesser code. It will it will avoid any unnecessary running of the entire loop. Okay, while loop condition is tested as with all other loops. It's tested every time, and it's tested before the loop begins. If the condition is true, loop will begin. If the condition is false, loop will won't begin. Any line written outside the loop will not be part of the loop. Of course, this is before the loop. This is the end. So three types of loop, very interesting. Uh, when you have when you know the number of steps required, you will go for the counter control. When you don't know the number of steps required, you will use either one of these. Okay. Then there's this concept of rogue value. Now, rogue value is something that basically means that it's a value that causes the sequence or a loop to terminate. So for example, my loop here my while loop here will keep on running until the next number is 0. So this next number z is not equal to 0 is a condition that will cause my loop to exit. So if my next number becomes 0, that means this condition becomes false and I will exit the loop. So if next number is 0, that is my terminating condition. So this loop will run as long as I don't input a number 0 in it. So 0 becomes my rogue value. It will cause my sequence to terminate. Same thing goes over here. I will input next number and I will keep on taking inputs until the next number is 0. So again, this is example of what rogue value looks like. Now, coming down to stepwise refinement. Stepwise refinement is the process of dividing your larger problem into sub-problems until each problem results in either a procedure or a function. Now, subroutines uh, uh, basically are programs within programs. They are enclosed in their own set of statements. The benefit of writing subroutines is that you can write a part of the program, and if you need that part of the program again and again, you don't have to rewrite it again. You can simply call the subroutine. So it makes it easier and shorter code. We'll be looking at some examples for subroutines in a bit. But the important thing is, whether are you going to use a procedure or function, that depends on the problem at hand. What is the difference between these two? Well, a procedure is a subroutine that simply has its own statements. It executes those statements, and that's the end of it. It does not return any value. It does not produce any results. It's simply responsible for carrying out statements. So if you want simply your subroutine to execute a few statements, change some values around, and that's it, present some prompts and whatever it is, but you don't require any values to be returned, then you will go for a procedure. On the other hand, if your requirement is that a few lines of it to be executed and the result has to be returned, in which case you will need a function. Functions always return values, procedures do not return no value. So the choice between these two largely depends on the problem at hand. Okay. Similarly, as mentioned before, if you are using flowchart and you want to show a procedure call, by the way, okay, how does your pseudocode, by the way, show a procedure call? You'll have to mention your call keyword first. Okay, so if you write a procedure, say I wrote a procedure by the name of XYZ. Excuse me. First of all, you have to notice that before you can use a procedure, that means calling a procedure, you have to write a procedure. So once you have written the procedure, that means, for example, I wrote these functions here, wrote this procedure here. Whenever I've written a subroutine, only then I can call it. So let's just say I've written the procedure output symbols, and this is what it's supposed to do. So every time I want to use output symbols, I will simply call output symbols like it's done over here, and I don't have to rewrite it. I don't have to rewrite all of this code and again. So that might it makes my sub in my overall coding effort lesser. But if I want to call this subroutine, this procedure, output symbols, I will have to use the call keyword. Output symbols is a procedure, and I will call it using the call keywords. However, with a function, I don't need a call keyword for a function. Function is supposed to return a value. So when I simply address that function by its identifier, so for example, adjust number of spaces is a function. I have simply called the function by simply calling out its name. I don't need to call the call keyword here. Adjust number of spaces will be returning some value. It's a function. The value that it returns, I want it to go to the number of spaces. So if you want to use a result produced by a subroutine in other operations, as it's done over here, that it's returning a value and I'm assigning it to number of spaces. So if you need something like that, then you will go for functions. But if you do not require that, you don't require any results being produced, you can stick to writing a procedure. So this is just a quick recap of our basic introduction of our algorithms in the terms of flowcharts, pseudocodes, and the different constructs and their variations that you will be encountering in the in later part of the syllabus.